A very good morning to all. Today we are going to start the second unit. In the second unit, we are going to discuss about 8086 microprocessor. So first today we are going to study the introduction regarding the 8086 microprocessor. Later on we will be going for the architecture, memory, segmentation, register organization, its features in detail. But for today, we are going to study the introduction to microprocessor. So first of all, what is a microprocessor? Microprocessor, with its name, it indicates micro, a small, nothing but a small chip, a small integrated circuit, processor, process the tasks, processing the data, process the data required by the user. So whole in a totally we can call it is a small chip which is acting as the controlling unit of the user, which is processing the data in order to do its task. In a whole, we can call a microprocessor, it is a heart of the computer. It is a heart of the computer. So, as you all know, for a human, if heart works, heart will be working the human. If heart is failed, the human is died. Similarly, in the computer, there is one part which is a central processing unit, which is a microprocessor. It is the heart of the computer. If there is no CPU or if there is no microprocessor, we can call a computer as a dummy. It will not do anything, it will not function. So without microprocessor, there is no computer. So microprocessor is the heart of a computer, nothing but it is a controlling unit which is being wrapped up into a single chip. You can call micro a small chip that performs various operations that can be arithmetic, logical, any type of operations to process the data depending upon the requirement of the output device. Or you can call user. So CPU is my microprocessor, so you can able to connect the external memory like your SD card, like your pen drive, like your hard disk, etc. And we can able to connect externally the IO ports, nothing but input or output ports. You can connect keyboard, mouse, printer, scanners, etc. So it is able to store, or you can call possible to store the data in and only external memory. Right? So overall, how this microprocessor functions: input devices are being connected, output devices are being connected, memory is being connected. So whatever the input device we are allotting or we are giving, we are asking the microprocessor will be fetching the instructions from the memory, decoding the instructions and executing the instructions, and depending upon the output device, it produces the output. This is how the microprocessor working will be. We have one more device, or we can call a chip, which is a microcontroller. See here, microprocessor. Here micro is common, nothing but they are wrapped into a small chip. It is a controller, it is a processor, nothing but In the controller, there is a processor inside. There is a processing unit inside. Sorry, you can call processing unit inside. We can have a memory, some type of memory, some I/O ports internally. On a whole, it is making a computer into a small chip. Getting point here. It can have internal memory as well as external memory. So whatever the data is being processed by the semiconductor device, by the microcontroller, which performs arithmetic and logical operations and any number of operations, it can able to store the data into memory as internal or external. And one important point regarding microprocessor and microcontroller is microprocessor can be able to do multiple number of tasks at a time. Microprocessor, it can able to perform only one task or function at a particular instant of time. Now we are going to study from which things this microprocessor has been developed. Before the first the microprocessor was being developed was in 1971, which is a 4-bit microprocessor. So the first processor, which is a 4-bit, was developed in 1971 by the Intel itself. The number is 4004. So 4-bit, nothing but the data is a 4-bit data. So at one particular instant of time, it can able to transmit a 4-bit data. Getting point here? So what do you mean by this 4-bit means? A 4-bit data is being processed at a time. Okay, so if I need to send more amount of data, so it takes more amount of time. So in order to remove the wastage of time, Intel only developed a 8-bit microprocessor in the year 1972. Okay, 8-bit data. So 8-bit data which can able to process at a particular instant of time. So depending upon some features to be added, 8-bit microprocessor versions have been evolved as 8080 and 8085 in 1974. Now still the 8-bit data we can able to process, but if you want to go for higher amount of data, we require more amount of time. So 16-bit data if you want to process, we require 2 cycles in order to complete one transaction. So in order to remove that flexibility, 8086 was developed by the brains of famous IBM PC as a 16-bit processor. Okay, later on it being developed as 32-bit, then coming bit 64-bit. Now the latest Core i3 generation, we have many famous microprocessors being developed by the Intel company. So it is the most important advances in the computer technology. Okay, since 1970s it has been developed and dominated by the Intel, and since now it is being going on in a very rapid speed. Sir, I have a question in here. Sir, today they are using some Core i3 processor. Why we are studying this 8086 processor, sir? My answer is Core i3, which is the advanced technology, is useful for processing some excess amount of data. Nothing but more complex data if you need to process, we can go for or I3. But a very simple instructions, very simple bit of data which we can process, which we can able to do, we have to use 8086 processor. See, our laptop and our phones are advanced stage of microprocessor. But whereas some devices like our fridges, not fridges, I can take a washing machine, simple washing machine, okay, where it can perform only some 3 to 4 tasks at a time. So for that we can go for a simple microprocessor, not going for the advanced technology. Getting your point? That's the reason why we are studying this 8086. Clear, I guess. Next. Now we'll see some comparison between 8085 microprocessor and 8086 microprocessor. Until now you know that 8085 microprocessor is a 8-bit microprocessor, whereas 8086 is a 16-bit microprocessor. Okay. Some more differences we are going to see here. 8085 has 16-bit address bus, 8086 has 20-bit address bus. This is one more important point. Address bus 16-bit, address bus 20-bit. Nothing but 2 port 16 address lines, 2 port 20 address lines. Nothing but 65,536 address lines. Here 1 mega address lines. There is a small increment in your address lines so that more amount of data can be stored in your 8086 processor. Memory, as you all know, 2 port 16 nothing but 64 kilobytes, and 8086 can have 1 megabyte of memory. Now instruction, nothing but 8085 doesn't have an instruction queue. Nothing but queue is nothing but we can able to store the data in a queue. It is a storage of data. Queue, first in, first out. 8085 doesn't have this queue. Nothing but 8085 will have to fetch the instruction from a memory, decode it, execute it. Again go to fetch, decode, execute. This is how your instruction cycle will do, right? So 8085, if it doesn't have any instruction queue, it has to wait for fetching, decoding, executing. After execution is being done, then it has to fetch, decode, execute. Like that, it continues. So what is the disadvantage of this one is, it is waiting for the next instruction to be fetched. Whereas 8086 has a queue which can able to prefetch the 6 byte of information, 6 byte of instructions in the instruction queue so that execution process continuous, fetching process continuous. Getting a point? Which takes a little bit of time compared with your 8085. Getting a point? Whereas one more important point is it doesn't support a pipeline architecture, while 8086 supports pipeline, nothing but prefetching the instructions. Coming to the 8085, as we all know, it is an 8-bit microprocessor, nothing but 2 power 8, which is 256 IO lines, whereas 8086 is a 16-bit microprocessor, which can access 2 power 16 IO lines, which is 65,536 lines. Okay, so comparing the cost, 8085 is comparatively low, and 8086 is comparatively high, as features are being added. Now coming to the features of 8086, as we all know, it is a 16-bit microprocessor. It has 20-bit address bus that can access up to 2 port 20 memory locations. It can support up to 64 kilo IO ports. It provides 16-bit registers. Word size, well known, 16 bits. Double word size is 4 bytes. It has multiplexed address and data bus, AD0 to AD15, A16 to A19. See, as the data bus is 16-bit, so address and data bus are being multiplexed by AD0 to AD15 and the 4 address bus which are A16 to A19. 8086 is designed to operate in two modes, minimum and maximum. It can fetches up to 6 instruction bytes. It requires plus 5 volts power supply. It is a 40-pin dual inline package. Address ranges from 50 to 5F. For today I will stop here. I will continue in the next session.